Hi, my name is Trevor and welcome to this video about anisotropic surfaces in GeoStudio. Anisotropic surfaces can be used to generate directionally dependent shear strength. Soil and rock exhibit anisotropic strengths due to the presence of discontinuities, where the strength of the discontinuities varies considerably from the surrounding intact material. In contrast to a weak layer, an anisotropic surface does not impose a direct control on the shape of a slip surface. Anisotropic surfaces are defined using a polyline in 2D. The input properties of an anisotropic surface include a base material representing the intact soil or rock matrix, a material representing the discontinuity, and two angle ranges, A and B. The A and B parameters associated with each anisotropic surface are angular tolerances around the discontinuity. These control the transition of shear strength from the anisotropic material to the intact material. The solver calculates the shear strength based on the angle between the column base and the anisotropic feature. Within the range of A, the discontinuity shear strength is used. Outside the range of B, the shear strength of the base material is used. For angles between A and B, the shear strength is computed based on a linear interpolation between the shear strengths of the base and the discontinuity materials. You can see a figure depicting the different search techniques available for anisotropic surfaces where the reference point is the midpoint of the column. Alpha is the angle of the anisotropic surface at the point found either horizontally closest, vertically closest, or closest overall. Let us get into the workflow for creating and drawing anisotropic surfaces. My first step is clicking on Draw, going down to Surfaces, and selecting Anisotropic Surfaces. This grayed out drop-down means I have no anisotropic surfaces yet, so I click Add. Now I can select my materials. My base material is my intact material, and I want this to be disturbed shale. My anisotropy material is the discontinuity. I have already created this material called anisotropy material. If I click on the ellipsis, I can see the properties. I have set this to a friction angle of 5 degrees. I can now close the Define Materials dialog and switch to the Properties tab of the Draw Anisotropic Surfaces dialog. I set my angle A to 3 degrees, and I set my angle B to 6 degrees. The closest distance search mode is the default. You can click on the drop-down to access the other search modes. Now that I have set all my parameters, I click Draw. In this case, I will use the points since I want this anisotropic surface as the interface between these two materials. However, when defining an anisotropic surface, you do not need to follow pre-drawn lines on the domain. Your anisotropic surface can cut through a region. Now I can right-click to stop drawing the line. If I zoom in here, you can see the anisotropic surface line is comprised of 1 dash and 2 dots, which is different from other surfaces. If I go to my Define Project dialog here and click on the Slip Surface tab, you can see I have also selected Optimize Critical Slip Surface Location, since the anisotropic surface does not impose control on the slip surface. Now I close the Define Project dialog and click Start. The analysis is now solved, and you can see the unoptimized slip surface is a circular slip surface. The optimized slip surface, with a lower factor of safety, has a flat bottom. The optimization flattened the bottom of the slip surface due to the low strength parameters of the anisotropic surface. The anisotropic surface did not impose this shape on the slip surface. Thank you for watching today, and I hope you enjoyed the video.